Learning target 1C is name the transformations from the parent function given the graph. So let's look at example 1. What is the transformation from the parent function? So it's always from the parent function. It's very important that you know that it's from the parent function. So it's always from the parent function. So one thing I tend to do, I look at the parent function or the shape of the graph, and that's a cubic shape. So I would just draw in the actual parent function. So then I know like where these points come from and where, so I just kind of draw in the general shape. This isn't actually your answer, but it kind of gives us an idea. So 0, 0 here, where is that on the actual graph that is given? Well, that's right here. And what happened from 0, 0? It went up 3. Let's just check with another point. So 1, 1, where would that be? That's up here at 1, 4. So it looks like the cubic graph, the cubic function, got transformed up 3. So the cubic function you could say transforms, translated, moved up 3 units. And that's it. So it's always from parent function, move. Example 2, so what is the transformation, or transformations it should say, from the parent function? So what parent function is this? It's absolute value. That goes through 0, 0, 1, 1, negative 1, 1, and it's a V-shaped. Well, what do you notice right away about this V-shaped? Well, it's upside down, so we know that it is, what is that called? That reflection. Reflection is reflected, and we only reflect this year over the x-axis. So we know it's absolute value function, and we could just shorten it up to abs value. Oh, that's not an E. So absolute value, abs value, that is reflected. And what else is happening? So if we reflect it, it's going to be upside down. So you always do reflections right away too. Make sure you're always doing reflections right away. So it would look something like this. I'm just going to do a dashed line. So it'll be a V, and then it's going to move 3 to the left, 2 down. So 3 left, 2 down. Moving on to another one. So what is a transformation from the parent function? So let's look at what type of parent function this is. It looks like a log function. It's got this tail down here. Log function goes through 1, 0. And then it runs right along the x or the y-axis and comes up and cuts over quickly. So with a log function, it's kind of tricky to figure out what the point is. Remember, there's an asymptote that runs right along the y-axis here. And so that's one point to the left, one vertical line to the left of 1, 0. So if we look at our tail here, it's running right along 2, where x equals 2. So if we go 1 to the right, here's our point. So that's where 1, 0 got transformed to. It's kind of right in the middle of the, kind of towards the end of the curve, I guess, of the turn here. So how's that transformed? First, it's a log function. You don't have to say logarithmic, it could just be log function. And it is transformed 2 to the right and 3 up. And there's no reflections, it's a general shape. Next one, what transformation? It's always from the parent function. What parent function is this? That is rational. Rational starts at 1, 1 and negative 1, negative 1. And then there's asymptotes along the y-axis and the x-axis. And so you just draw a graph that doesn't touch or doesn't go through them asymptotes. It just stays on just along the asymptotes, curves straight along the asymptotes. Not the best graph in the world, but maybe we can look at this. So 1, 1, that part of the graph looks to be this shape, this side, the graph, this part of the graph. And where would 1, 1 be? So I just look for nice points along this line. The only one I really see is at 0, -3. So this point here got transformed down to 0, -3. So what happens? It goes down 1, 2, 3, 4 until left 1. If we want to look at -1, -1, we could look at that point and see where would that get transformed. And it looks like it would get transformed right down here. So that again is down 1, 2, 3, 4 and left 1. So this looks to be a rational function. And it is translated down 4 and left 1. Alright, next we have, given the transformations from the parent function, draw the graph. So this is just the opposite of 1c. So give the graph, for example 5, give a graph of a quadratic function transformed 3 units to the left and 2 units down. So you got to think about a quadratic function. It starts at 0, 0, 1, 1, and -1, 1. So think about, and it's U-shaped, quadratic, U-shaped, and if we move it 3 units to the left and 2 down, so I'll start at 0, 0. If I move that 3 units left and 2 down, it's here. So 0, 0 got transformed to -3, -2. 1, 1, 3 units left, 1, 2, 3, 2 down, -2, -1, and -1, 1, 3 left, 2 down, and you're at -4, -1. So the graph that we need to draw, it's quadratic, so U-shaped. Not going to be a perfect graph, but pretty good. U-shaped there. Moving on to the next one. Give the graph of a cubic function transformed 3 units to the right and 4 units down and reflected across the x-axis. Always do it in the order that they give it. In general, if you know that if a graph is given, you always say it's reflected first. You technically don't have to, but it's much easier, I believe. But always do this. So cubic function. Again, I draw in the parent function just to kind of get a visual. So we have 1, 1, 0, 0, -1, -1, and it's really steep, snake-like. And we're going to make this go 3 units right, 4 units down, and then reflect it. So this is crazy, wild. So I just start at 0, 0, go 3 units right, so we're at 3, 0, 4 units down, and then we're going to reflect that point here across the x-axis. So where would it go if we reflected it across the x-axis? It's kind of like folding this graph right along the x-axis. Where would that point go? Well, it would actually go all the way up to 3, 4. So that's the new point. So that's from 0, 0. Let's do the same thing from 1, 1. So we go 3 right, 1, 2, 3, and 4 units down, 1, 2, 3, 4. So we're at 4, -3. Reflect that across the x-axis, boom, it shoots right back out to 4, 3. And then the last one, -1, -1, go 3 right, 1, 2, 3. You go down 4, 1, 2, 3, 4. So we're at 2, -5, and we reflect that across the x-axis. That'll be go to 2, 5. The other thing we got to think about, if we reflected this across the x-axis, what would the shape be? You got to think this right side that goes up here, that goes down. This left side that's below the x-axis would actually reflect up. So the shape of this graph actually is kind of backwards. So right side goes down, left side goes up. And this is the graph you need. That is the answer I'm looking for. And that is it. So come to class with any questions. Thank you.